we're talking about preparation of carbon dioxide. But want to see something that when you open your Coke, your mineral, because carbonates were used to preserve Cokes, used to preserve your minerals. When you open it, the carbonate that has been stored inside, has been staying there for quite some time, tries to escape. That's why when you shake it, or when you try opening it, you hear that sound, that effervescent sound, effervescent, I just want to come up. That's to show you that carbon dioxide was present in that Coke, trying to escape. Okay, now we'll be looking at how do we prepare carbon dioxide in the laboratory? How do we prepare carbon dioxide? Very, very instructive. Okay, let me see. Coming. Okay, preparation of carbon dioxide in the laboratory. Okay, please just write this. Laboratory preparation of carbon dioxide gas. Laboratory preparation of carbon dioxide gas. Okay, carbon dioxide is prepared by reacting calcium carbonate, that's calcium trioxocarbonate 4, by reacting calcium trioxocarbonate 4 with hydrochloric acid. With hydrochloric acid. With hydrochloric acid. Now, right, pure and dry CO2 is obtained. Pure and dry CO2 is obtained by passing the gas. By passing the gas through a solution of potassium hydrogen trioxocarbonate 4. By passing the gas through a solution of potassium hydrogen trioxocarbonate 4. To remove the acid impurities. To remove the acid impurities. To remove the acid impurities, hydrogen chloride. To remove the acid impurities and hydrogen chloride. Okay, then right, it is then passed through conc H2SO4. It is then passed through conc H2SO4, that's concentrated H2SO4. Of fused calcium chloride. Of fused calcium chloride. Can you tell me why do we pass them through conc H2SO4 or fused calcium chloride? When we talk about acid, about salts, I mentioned something there when we talked about properties of salt. I talked about something there. Why do we pass gas through H2SO4 or fused?
To dry it.
Good, to dry the gas. To dry it. Very simple. To dry it. Okay. Now, it's passed through conc H2SO4 or fused calcium chloride to dry the gas. Okay. Let's write the equation of the reaction. I guess you should know what will be given now. Calcium trioxocarbonate 4 plus hydrochloric acid, giving you calcium chloride. Remember I told you whenever you have carbonates, whenever you have a carbonate reacting, I told you that two things must come out, apart from another one that would come out. But two things as a constant must come out. What can you remember them?
Water and
Water and what?
carbon.
Yeah, water and carbon dioxide. So we'll be having calcium chloride plus water plus carbon dioxide. Okay, have you balanced the equation?
CaCO3 plus 2HCl giving CaCl2 plus H2O plus CO2.
Okay.
LA is distributed.
Let's
LA is distributed.
Let's look at other ways. Okay. Okay, I'll give you this as assignment. But let's look at, I think I have a video that illustrates, that could help illustrate. Don't worry, I'm going to show you something. Okay. Where are you, please? Different methods. Wow. My God. Are you serious? I didn't really download this. Okay, let's just see this preparation of carbon dioxide. Just a science experiment. This one you can try it at home. Carbon dioxide is not harmful. It's not that harmful. There's something I'm going to ask you later on it. Okay. Are you seeing it?
Yes, sir.
Okay. Wow. Does this look like something you see during when you open your gas? I mean your what do you call it? Your mineral?
No.
Really? That's because it's in a liquid form. But I guess you're going to be seeing. But do you think it's something you can try? Can you try something like this?
Yes.
Okay. If possible, I would like you to do that though. I would like you to do that. Okay, you're gonna share your experience. Why I want you to do this is when you start doing your practicals on salt analysis, when testing for carbon 4 oxide, your experience doing this is going to help you. It's going to help you because when you start reacting some salt and you saw that effervescence, you see that effervescence in the carbon 4 oxide, number one, you see that it's an odorless gas. It doesn't harm. It's an odorless gas. You see that it's colorless. That tells you that it is carbon 4 oxide. These are some of the ways we know that this is carbon 4 oxide. Okay, I'm also going to show you a video that where test for carbon 4 oxide was carried out, so that you can try this one, you can try this at home, but the other one in the laboratory. Since you are not in school now, I'm going to be showing a video of that, but let's just finish this, please. Okay, now I'm going to be showing you this. Let's see a practical preparation. A practical preparation of carbon 4 oxide, how it was prepared in the lab, so that even when school resumes and you're seeing this, you have an idea what we're talking about. Practical preparation of carbon 4 oxide. Then we'll come to the properties of carbon 4 oxide. Sorry, can you see this?
Yes, sir.
Okay.
So into our dropping here, Connor. That's excellent, very good. And in our last one we got calcium carbonate. 2 forms of calcium carbonate we can see here. We have the powder form, which is marble. Okay, so they're both calcium carbonate. So we can see our equation here. When you react calcium carbonate and hydrochloric acid together, you get calcium chloride, which is a salt, carbon dioxide, a gas, and water. Okay, so our carbon dioxide is going to move along this tube and into our collecting gas jar here. Okay, and Jack is holding that for us. Good man, Jack. Good job. Okay, so I'm going to add acid out of the dropping funnel into our flask. Now I'm going to give it a good swirl. Give it a swirl to allow the acid to form. Now, unlike when we prepared the oxygen the last day, we could see the level of the water going down. In this case here, we can't actually see the carbon dioxide because it's a colorless gas. Right? So what's happening is that carbon dioxide is going to move along here into the gas jar and push the air that's in it out. Okay? So the only way you can tell to see if we have enough CO2 is to test it, which is what we're going to do in a moment. Right? So I'm going to test and see if we have some carbon dioxide. And if we have, we'll try and find another jar. Now, I have a splint here that I've just lit with our Bunsen burner. We hold, if I put it into carbon dioxide, what will happen at? Yeah, good man, it's a good clench. So Jack will just lift the lid there and we're going to see with a clench. And it does. Okay? And that leads me to believe that we have what? Carbon dioxide. That's one of the tests. I just hold that there for me face down. Now we're going to collect one more jar of it. So I'm going to add some here. Inside of this one here, the water has been formed and calcium fluoride. Well, add more. Get some more CO2. Another we're going to light. And there's a light light. We're going to take our gas or a jar of CO2. Into and it sinks to the bottom because of how does its density compare to air? Excellently well. It's more dense than air. Fantastic. Very, very good. Now, we told them there from the again, Jack. And what we're going to do is we'll select one more jar, right? Especially transfer it into this one. Right, because I've poured that one out. So we just roll back this, Jack. Thank you. And we're going to try to collect some more. Carbon dioxide has been very successful so far. So that's more acid. And one other test that we'd like to do is see what kind of an oxide is carbon dioxide. Is it acidic? Is it basic? So to see if it's acidic or basic, we're going to react it with litmus paper. Okay? And I have red litmus and I have blue litmus. Now, it's a little bit difficult to
Before we continue, I want to ask you, what thing, with what you just watched, before we continue, I guess we still have some things. Now, she wants to do something different, and which you're going to write. What did you notice about carbon dioxide?
It can stop burning.
Sorry?
When clothes close to fire, it stops the combustion.
It stops combustion. Good. So what can you conclude? Now, that was an observation. What can you conclude now about carbon dioxide?
Hey, it's a problem.
What can you conclude?
It is a water dust.
Sorry? Anything?
No.
Okay. Now, you know how scientists make their conclusion? They make their conclusion from what they observe. Now, from what you've just observed, you should be able to, you've just given me observation, because why I'm asking you this, it's there's something that I'm asking you. Number one, you're going to do your test. Number two, you do your observation. Number three, do your inference. Your test is what she has just done. Your observation is what you just told me now. Now your conclusion is, now, okay, that's what we talk about, the scientific methods. You learned that first time in chemistry that there's an hypothesis, there's actually a guess, hypothesis, a theory, and then there's a law. Now, we want to establish a law based on what you have seen. You've not tried it out, but to an extent, they are trying it out, and we believe what they are doing is true. So what's the law? What can we bring out now? One of the things you can bring out from what you just watched is, one, carbon dioxide does not support combustion. It's a law. Carbon dioxide does not bring carbon dioxide towards any burning substance to quench it. Right?
Yeah.
From what we just seen. Now, the thing now is, how does fire extinguisher also quench your fire? The main component in fire extinguisher is carbon dioxide. That's why if they ask you what is the major instrument gas in fire extinguisher, it's actually your carbon dioxide. Why? Carbon dioxide does not support combustion. Because it does not support combustion, it can quench fires. Just the way you saw it was quenching the fires there. So it's one of the major instruments used in fire extinguishers. All right. Now, we also know it's a colorless gas. Let's continue. Now, she wants to do something. Want to see the action of carbon dioxide on litmus paper. So I will need you to be careful of that now. Just watch that. I think that's the next thing she wants to do.
And what I'm going to do, I'm going to add some sure. I'm never going to test and see. Hopefully we have enough food. I'll just add a little bit in here. Now, carbon dioxide, you should know because it's for fizzy drinks. So we're going to test and see if we've got an acid. So we're going to add blue litmus and red litmus. And we all know that acids will turn blue litmus. Excellent. Very good. We're going to test and see, will it turn the blue litmus red? Okay? That's what we're hoping for. We saw the last day that the magnesium oxide was basic oxide. So we're going to test it. We'll turn it red or not. We'll see if we have enough CO2. So it's going red. Slightly, yeah. So I think we've got some. Did it do anything to the red? Doesn't look as if there's any change.
Okay, welcome back. Okay, let's continue now with litmus. Oh God, what's this? Sorry. All right, let's continue.
We have enough CO2. So it's going red. Slightly, yeah. So I think we've got some. Did it do anything to the red? Doesn't look as if there's any change. So I think we'll take that as a success. We can see some of the blue here it has gone. And the red one hasn't changed out.
Are you there? Okay, are you there?
Yes, sir.
Okay.
So carbon dioxide is in acidic oxide. That's excellent. So I'm going to hand it over to you and you're going to prepare your own samples of CO2. Well done.
Okay. Now, what do we notice about carbon dioxide and what do you call it? Litmus paper.
So I didn't see the litmus paper.
Oh, you didn't see it? Really?
Yes, sir.
Okay, but let me just tell you then. Carbon dioxide has no action on litmus paper. It is neutral to litmus paper. It is neutral to litmus paper. Very instructive. To red, she tested it with red and blue litmus paper, and it was neutral to it. So number one, it's a colorless and odorless gas. Number two, that's the physical properties which we've seen. It does not support combustion. It is neutral to litmus paper. All right, those are properties of carbon dioxide. Those are properties of carbon dioxide. Now, the next thing is let's look at the chemical properties. Let's look at the chemical properties of carbon dioxide. Sorry, I think I have something else. I'm coming. Let me look. Let me check this out.
This video, gas. That's in the other reaction.
Okay. Maybe I'll give that to you as an assignment. All right, chemical properties of carbon dioxide. Chemical properties. Let's write that. Number one, it dissolves in water to give trioxocarbonate 4 acid. It dissolves in water to give trioxocarbonate 4 acid. It dissolves in water to give trioxocarbonate 4 acid. Okay. Now, this is the equation. This is the This is the equation. We have water plus CO2 giving us trioxocarbonate 4 acid. So it dissolves in water to give us trioxocarbonate 4 acid. Number two,
So can you the equation again?
he said, okay, the equation.
So the equation.
Have you gotten that?
Yes, sir.
Okay. Oh, did I tell you it was neutral to litmus paper?
Yes.
No. Please cancel that. It's not neutral, please. It's an acidic gas. It's not, so it can't be neutral. If you take a blue litmus paper and put in carbon dioxide, it will not do anything. So how do you test for gases using whether they are acidic gas or alkaline gas? What you do is this. The litmus paper, soak it with water, make it damp a bit. Then it's going to turn it red. But if you don't make it damp, it's not going to do anything. So it will look as if it's neutral, which is not. So number two, it turns damp blue litmus paper red. It turns damp blue litmus paper red. Remember, whenever you want to test for gases using litmus paper, make it damp. Make it damp. It's only when you are using a liquid and you could use it like that. But if you want to test for gases using litmus paper, make it damp a bit. So it turns damp blue litmus paper red. Okay. Number three, it neutralizes base to give salts and water. It neutralizes base to give salts and water. It neutralizes base to give salts and water. What we're trying to say is this is the equation. Let's just neutralizes base to give salts and water. Okay. Okay, we have CO2 plus, this is a base. The salt is going to be giving us is SOCO 3 plus okay. I need you to balance this. Having issues?
No, sir. plus H2O.
Sorry?
CO2 plus 2NaOH giving Na2CO3 plus H2O.
Okay. Good. The next one, it's the next one is okay. It reacts with lime water to form calcium hydroxide. It reacts with lime water to form calcium hydroxide. You know how to write calcium hydroxide?
CaOH.
Not that. CaOH. Remember, Ca is 2. OH is 1.
CaOH.
Sorry?
CaOH2.
Good. CaOH2 in brackets. So react CO2 plus CaOH2 is going to be giving you calcium triisocarbonate 4 plus water.
It's
Going to be giving you that CO2 plus calcium hydroxide. It will give you calcium triisocarbonate 4 plus water. Okay, have you written that?
Yes, sir.
Okay. Let me check if it's balanced. This is 2, 2. Okay. I guess it's balanced. So there's no need balancing it. Now let's look at the uses of CO2. Uses of CO2. Number 1, it is used in fire extinguishers because it is heavier than air. It is used in fire extinguishers because it is heavier than air and does not support combustion. It is used in fire extinguishers because it is heavier than air and does not support combustion. So these are the 2 reasons why we use CO2 in fire extinguishers, because number 1, it is heavier than air. Number 2, it does not support combustion. Okay. The next one, it is used in the production of aerated drinks. It is used in the production of drinks such as Coca-Cola, 7-Up, Pepsi, Coke, Fanta. It is used in the production of drinks as a preservative. So it works there as a preservative. It works there as a preservative. Okay, number 3, it is used as effervescence. It is used as effervescence in certain health salts. It is used as effervescence in certain health salts. It is used as effervescence in certain health salts. Have you taken Andrew liver salt before?
No.
Sorry?
No, sir.
Okay. Okay, have you written that?
Yes, sir.
Okay. Now, the next one, it is mixed with tartaric acid. It is mixed with tartaric acid and cornstarch. It is mixed with tartaric acid and cornstarch to form baking powder. To form baking powder. Okay. Okay, the next one, it is necessary for photosynthesis. It is necessary for photosynthesis. What's this? It is necessary for photosynthesis. Okay, I guess, let's see. Okay, please write this one. Solid CO2 in bracket dry ice. Solid CO2 in bracket dry ice is used as a refrigerant. Is used as a refrigerant in preserving food. Solid CO2 in bracket dry ice is used as a refrigerant in preserving foodstuff. Now, now if we know something about dry ice, that's solid CO2. Dry ice actually, it sublimes readily without forming liquid. You know what they call sublimation, right?
Yes, sir.
Yeah, that's something turning from solid to gas without going through the liquid phase. Now, the question now is, what is the advantage of dry ice over popular ice? Popular ice has to turn to liquid, but dry ice doesn't turn to liquid. It sublimes directly into the gaseous stage, from solid to gaseous. Okay, let's look at this. Advantages of dry ice over popular ice. Advantages of dry ice over popular ice. Okay, number one, dry ice provides a greater cooling effect than equal mass of ice block. Dry ice provides a greater cooling effect. Have you written that?
Yes, sir.
Okay, number two, dry ice on warming sublimes, unlike ice which melts to produce. Yeah, I said dry ice on warming sublimes. Dry ice on warming sublimes. That it changes from solid to gas. Unlike ice which melts to produce water. Have you written that?
Yes, sir.
Okay. Now, another thing else we should know, please, as a caution, dry ice is quite dangerous, so it's advisable that you don't handle dry ice with your bare hands. They cause painful blisters. similar to those ones caused by hot objects. When hot objects are on your hand, they cause painful blisters. The same thing with dry ice. It's so cold. So never handle with your bare hands. All right. Okay, that's awesome. That's awesome. Oh, 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 oh. I just noticed I passed something. I told you that CO2 reacts with lime water to give. I told you to react with lime water, right? To give carbon, triacylcarbonate 4 and water, isn't it?
Yes, sir.
Okay, but please, just continuation of that. I didn't say something. I just saw a question on it. And I think it was quite instructive. I gave you that also. Please write this. When it lasts for a long time inside lime water, when it lasts for a long time or for a longer time inside lime water is actually Ca, calcium hydroxide. When it lasts for a long time inside lime water, it gives the following. When it lasts for a long time inside lime water, it gives the following. Please write this equation. Calcium carbonate, that's the product that was formed. Calcium triacylcarbonate 4 plus H2O plus CO2 giving you Ca brackets HCO3 bracket 2. Now that is actually calcium hydrogen trioxocarbonate 4. That's a colorless solution. So when it lasts for a longer time inside lime water, it gives that compound, calcium hydrogen triacylcarbonate 4, as a colorless solution. All right. Have you written that, please?
Yes, sir.
I think I have something else to show you. Don't worry, we're almost done with these guys called we're almost done with them. We're almost done with them. I think I've given you the major things. The other ones are just carbon 2 oxide. Can I just rush to carbon 2 oxide? Or let me show you. No. Let's go to carbon 2 oxide. Straightforward. I just want us to end with carbon so we can go into hydrocarbons. All right, let's talk about carbon 2 oxide, please. Carbon 2 oxide. Carbon 2 oxide. Okay. Now, we know something about carbon 2 oxide. It's actually a dangerous gas, very dangerous. So we cannot prepare carbon 2 oxide. Anybody preparing carbon 2 oxide like that is just going to die. But in too much of carbon 2 oxide affects the lungs. So what happens is we prepare carbon 2 oxide in a fume cupboard, not just in the lab. Yes, in the lab, yes, but there's something in the lab called a fume cupboard. It's used for preparing any poisonous gases like carbon 2 oxide, like hydrogen sulfide. Very, very dangerous thing. So we should know that laboratory preparation of carbon 2 oxide is in the fume cupboard. Number one way of preparing carbon 2 oxide, it's by, right, ethane diok acid crystals. Ethane, let me see if I could copy this thing and send to you. Ethane diok, when we come to organic chemistry, you understand what I mean by ethane diok, but I'm going to be sending it to you now. That looks okay. That is ethane dioxide crystals. Please, that H2 is down, 2 is down. And those numbers are down, they are not just like that. Okay, ethane dioxide crystals, all right? Okay, ethane dioxide crystals. Now, what happens is the decomposition of ethane dioxide crystals, sorry. Come in, let me see what to do here. Let me see if I could share this part. Okay. Okay, please write that ethane dioxide crystals down. Is the formula. Please write it down and put. It's just like put the straight arrow, like it's decomposing. Number one, it decomposes to water, H2O. Number two, it decomposes to CO, carbon 2 oxide. And number three, it decomposes to carbon 4 oxide. Decomposes to carbon 4 oxide. All right. Have you written that, please?
Yes, sir.
Okay, I'm coming. I'm trying to share something. I want to use that picture to explain something. Okay. Now this is it. I'm going to use this picture to explain what I want to say. This is how to prepare carbon 2 oxide. Coming. Okay, this is how to prepare it. We have ethane dioxide here. We have concentrated H2SO4. What's the purpose of concentrated H2SO4 again?
To dry.
Yes, to remove any water, to dry it. Now, when it's removed, the ethane dioxide crystal comes into these filter bottles. From these filter bottles into the next filter bottle, we have concentrated potassium hydroxide. Do you know the purpose of concentrated potassium hydroxide?
No.
Okay, it's to remove impurities from the CO2 gas. To remove any other impurities. From the CO2 gas. So from here, after writing that equation I gave you, you write COH plus CO2. Some of the impurities is going to be giving us K2CO3 plus H2O. So it's going to be removing any other impurities from it. Then our carbon 2 oxide is formed. Remember, carbon 2 oxide is formed in the is performed in a fume cupboard because it's a poisonous gas. So we don't want anybody to die, and that's why the fume cupboard does that for us. Okay, hope you've gotten that down.
Yes, sir.
All right. Coming. Okay, we did not balance our equations. Really? Okay, the first equation to balance it, just put 3 by H2O. It's going to balance it. But I need you to balance the second one.
So the second one.
The second, that's the one I just gave you now, CO2 plus KOH. Let's look at the physical properties of carbon 2 oxide. Number one, physical properties of carbon 2 oxide. Number one, it is a colorless, odorless, and a tasteless gas. It is a colorless, odorless, and a tasteless gas. Number two, it is slightly lighter than air. It is slightly lighter than air. Are you there? Okay. Number three, it is a poisonous gas. It's a poisonous gas. That's why we have it prepared in a film cupboard. The next one, it is a neutral gas. When we say it's a neutral gas, that means it does not have any action on litmus paper. It's a neutral gas. It's a neutral gas. Okay. Let's look at the chemical properties, please. Number one, it is used as fuel. It is used as fuel because it supports combustion. It is used as fuel because it supports combustion. It's so funny that CO2 does not support, while CO supports. Number two, it is used as a useful reducing agent. It is used as a useful reducing agent. Okay. I think the other ones we can do without it. Okay. I'm going to be giving these assignments. Number one assignment is list 2 other methods of preparing CO2, or not list, explain 2 other methods of preparing CO2.
So my assignment.
Yes, please. Number two, state the components of each of the following. State the components of each of the following. Number one, water gas. Number two, producer gas. Number three, coal gas. And number four, synthetic gas. Okay, have you gotten that? Hello?
Yes, sir.
Okay.
Yes, sir.
I'm looking for something else again. The next one, state a chemical test for trioxocarbonates. State a chemical test for trioxocarbonates. Okay. I think we're going to work with this. We're going to work with this. Okay, so let's call it off for now. The next time we'll be talking about hydrocarbons. So we'll come into hydrocarbons fully. That's quite more interesting. All right?
Yes, sir.
All right, let's pray, please. It's almost time for your class. Father, we thank you for today. Thank you for your grace. Thank you for your mercies. I pray for your daughter. Everything we've learned, I ask and pray for wisdom, understanding, in the name of Jesus. Thank you, Lord, because I know you've answered. In Jesus' name I pray. Okay, can you hear me?